Okay, so thank you. You are welcome. So the last time we looked at the first law of indices. Today we'll be looking at the second law of indices. Okay, we'll look at the second law and we'll see how it is. So second law of indices. So we have a to the power m all over or divided by a to the power n. A to the power m divided by a to the power n. Okay. Now, when you are applying this principle, you realize that the bases are the same, and the bases represent the a's. Okay, and the exponent, we have one which is to the power m and the other one which is to the power n. Okay, so we have a to the power m divided by a to the power n. Okay, now per the laws of indices, or per this second law of indices, it says that when you are dividing and the bases are the same, you subtract. You subtract the denominator, the exponent of the denominator from the numerator. So in this essence, we have n being subtracted from m. So when you look at it, you will see n is being subtracted from what? M. So this is what the principle holds. When the bases are the same, right? When the bases are the same and you are dividing, you what? You subtract the exponent. You subtract the exponent of the denominator from what? The numerator. So this is what the second law says. Now we are going to use this principle to solve problems, or to solve real life problems, or to find solutions to what? Problems in mathematics. Okay, so let's look at examples. Okay, now we have example 1. For example 1, we have 2 to the power 3 divided by 2. 2 to the power 3 divided by 2. Now, the exponent of the 2 at the numerator is 3, right? Now, the exponent of the 2, or the index of the 2 at the denominator, is 1. But in mathematics, we don't write it. So we have the 1 there, okay? We don't write the 1. The 2 is having power 1, but we don't write it, okay? Now, per the laws that we study, since the bases are the 2, when you look at the bases, we have 2 there. The 2 has one of the 2 at the numerator has the power 3, and the 2 to the denominator has the power 1. Okay. Now we have 2 there. The 2 are the same. So it means that the bases are the same. Now, if the bases are the same, what will you do when you are dividing? It means that we are going to subtract with the exponent, or the index, okay, or the powers. So it means that you will subtract the 1 from the 3 per the law that we study. It means that we are going to apply this principle, or this law, to what? Solve the solution, or to find solution to what? Example 1. Since we are subtracting 1 from 3, we'll execute our calculation, or we'll execute our solution. Okay, so we subtract 1 from 3. Okay, when you subtract 1 from 3, you'll be left with what? 2. Okay, so it means that you have your result to be 2 to the power 2. Okay, now 2 to the power 2 means 2 times 2. Okay, you multiply 2 twice by itself. Okay, now when you multiply 2 by 2, you have your result to be what? 4. So that means the result for example 1 is what? 4. Okay, so let's proceed to example 2. Okay, example 2, we have 5 to the power 5, all divided by 5 to the power 3. 5 to the power 5, all divided by 5 to the power 3. Now you realize that the bases are the same. So in this same way, we will subtract the powers, or the exponent, or index. So I will subtract 3 from what? 5. Okay, so which is equal to 5 to the power 5 minus 3. So we subtracted 3 from 5. Now you'll be left with 5 to the power 2. 5 to the power 2 tells us that 5 multiply 5 by 5, or multiply 5 twice. If it is 5 to the power 3, multiply 5 3 times. So 5 times 5 times 5. But if it is 5 to the power 2, you multiply 5 2 times, or twice. So that's 5 times 5. And 5 times 5 will give us what? The result to be what? 25. So this is the result for our examples. Okay. So keep on watching, and we'll bring you the next law. Thank you.